Last episode, we chopped out even more of our dwindling factory sheet metal to make room for some framing that now definitively ties the body and chassis together for better handling and safety. And that's great, but as custom fabrication combined with my OCD tends to equal long wait times for you in the best case, after several months away from the project entirely, we're back, and I'm ready to fire up the grinder. We mentioned previously about a new so-called front chassis support structure. The part that will bolt to this point on our firewall, which is tied into the rest of the body, and continue forward, past the future shock tower, and finish just ahead of the upper control arm.
So, that's all we've got to make. Easy.
This piece of filler rod is a bit flimsy for the task, but it's at least let us check that the concept works, even with the hood shut. And while it's looking like we'll need to do a bit of trimming, you get that on these big jobs. To get started then, let's clean up some scrap metal, as well as the ends of some DOM tubing, so we can cap off one side of it. This lets us fill the tube with sand after ensuring the twiglets were appropriately consumed to make the most ugly and overkill rain stick in the world. Or rather, that's what it would be if we didn't compact it down next, top it off with more sand, and weld the second cap in place to seal it 100% full. Trust me, it'll make sense. Now, it's not necessary for the caps to be perfectly circular for our use case, but you know, I can't live with them being only vaguely triangular. I'll argue it's to reduce puncture hazards, but you'll be happy to know that they're not perfect, in case you were going to call Bellevue on my behalf. Ah, the pipe bender. See, that should explain the sand. With any luck, it will help prevent the tube from crushing, as these benders are really handy if you want to bend pipe, but this is not that. Among the more technical differences, piping is measured on the inner diameter and tubing the outer. So we've chosen a piece that fits the die we have and not the other way around. Shout out to metal supermarkets for stocking 1 3/8 material. It is still by no means a perfect bend, but for the convenience of using a tool we've got, and by that I mean my brother's got but is left here as fair game, I am sufficiently happy with the results. And while we're here, we're going to need the same bend for the passenger side, so after some checking and more checking, it looks like we're pretty close.
And then I turn the camera on and it doesn't do... There!
So there's
we heard the sound.
well across there.
I'm seeing 42.5.
42.5. This side, 42.1. 0.4 of a degree difference, which means I'd have to move it 0.2 of a degree in this scenario up here to split the 0.4 on both sides of the bend, which seems like very little considering I have to account for spring back. How much do I actually have to move it to get 0.2 of a degree? I think maybe call it good enough.
Oh.
What do you think? You're the one always guiding me about this. Come on. This is what happens when we don't work on the car for about 4 months.
Good enough to move on? Is that what we're talking about?
Yes.
Good enough to move on.
I think we call it good.
Yeah, I don't know. Comments below. Fanatic builds. Fanatic.
I'm losing my touch.
All right.
The next thing you know, the car's going to be done next month because
yeah,
we
that's
don't
right.
care
Just
anymore.
don't care. I don't think so. Boy, that is pretty good. I think Fanatic builds can be happy with that.
That's the one side, that's the other side.
Given the piece of equipment we've had to work with.
Right. There's your inside. So you can see, obviously, like that really shows it there, just how much sharper
Sure, that inside bend is
than the outside. But look at the one outside to the other outside.
Yep.
It's 1/8 of an inch, roughly, out at the end, and probably about the same down here. Yep. In the middle, it's just under. It's like a 32nd of an inch less in the middle.
You do know what this means, right?
What?
It means that who cares about getting good enough to move on? Fanatic is still the way to go.
Joking aside, I am glad they're reasonably symmetrical, so with one cap cut off, the sand can be drained, and the other cap can follow before the whole thing gets sliced in two. Nice. I'm liking this. Now, keeping in mind it's still way too long, with the driver's side piece held in place, we've got a really good idea of how things will end up. And even if we imagine the tire in full bump at maximum lock, nothing's coming close to hitting. So this lower bolt down at the bottom here, if you can see,
Yep.
where the shock mounts up, it's going to come up through this cavity here, and the upper bolt will end up being somewhere just in here kind of area. So what we're going to have is 2 tabs coming off this tube that pick up the shock, and then 2 more tabs that come up off the frame here and also meet to that area. So 1 bolt will tie this piece through the shock into the frame, giving us a middle attachment point. We've got our rear attachment point here and a front there. So it really helps to sort of brace that whole unit together.
How'd you get that engine in there, by the way?
It just popped right in.
Just popped in. I don't know.
People don't know, but these cars are ideally suited to an LS swap, I'm telling you. So we're trying to figure out this angle to cut at the bottom here, and there's a couple of questions as to how we're actually going to attach this end, but the first things first is we at least need to get an angle transfer to it that matches up with where the frame rails are rising at the front of the car. So we took a whole bunch of angles with our little digital beep beep level here, and we brought it back to the welding table and have been able to jig things up and hold some angles and draw some lines until we're about right. And then what we've done is what some people have told us to do for a long time now, and that's create one of these little cardboard doodads, which we've just simply jammed some drill bits into, since I didn't want to cut up that much welding wire. And we have created a jig that is following that black Sharpie line, if you can just see on there. Now that Sharpie line is not in the correct height, it's just the correct angle, we think. But we have a Sharpie line drawn along the top here of this tube now as well, and a dot on here. And what I'm thinking is that, if I move it down a little bit, that line is more or less where the bottom of this should be. So I should be able to slide this to about there. Now the orientation hasn't changed from down at the base here, so the actual exact cut should be about right still. But now we look like we're closer to the correct plane. For some reason I was measuring the frame as 32 degrees earlier, and then you recheck it and it's 18. So whether the level did something funny or I don't know how to read. The fact is we got to 18 there, and then I'm using this cardboard because it also needs to be level in this direction, and at least I can get a bead line down here right now. So I've just been spending a little while here with Dad trying to get all of these sitting on the cardboard while the cardboard is sitting at the correct angle, or at least, you know, roughly at the correct angle. But I think it's pretty close, and what we should be able to do now is say...
Slide that sleeve back up.
It's a tight fit. You know, if I just hit it from the end... Well, it looks better than previously. You have zero reference, let's just put it that way. We've been working on this all afternoon, and I still don't know if what I'm looking at looks right, but I think it's about right.
To be sure though, we popped it in the car one more time and it appears things are finally sorted, which is super. And thankfully we don't have to trim down the other end, as there's a good chance that would affect everything we've just done. Right. Well, at least we remembered before it was too late. And fortunately, the angle is the same, we just had to slide the template down a hair to compensate. Up until now, we've been uncertain of how to finish this junction, but I think joining into the side of another piece of tube is going to be best.
That's our extra bit, which hopefully, if you imagine it more like that, but obviously this isn't the correct cut here anymore. It's ironic. We've done all of that to get to this, just to cut it off. But we had to do this so that we could actually figure out what the next cut is.
Yeah, because that is not the final cut.
No.
It's just temporary. Okay.
Yeah, ain't it great? Anyway, let's worry about that next cut in a minute. As with the first one done, something's not quite right.
It's not square to the side of the chassis. That would be square to the side of the chassis right there, but then we're off to the side of what the heck's happened? Thinking about things more, and you know, this is all part of the fun of the game, but where this looks like it's not centered on the chassis rail, because I wanted it right in the middle. The fact is, that's not where we've ended up, but I think we've accidentally done something on purpose, because this next piece which we just cut off, and we're going to end up fish-mouthing this into, it's going to sit square with the frame like that, and when this fish mouths into it, what that effectively does is it eats up into this length, which actually puts this very part centered on the frame. So I think this was actually a mistake that worked in our favor.
Well, we'll find out anyway. This next cut, being a fish mouth, appears to be more complicated than the first, but that's not entirely true. The first one established our angle, so now we just need to go 90 degrees to it. Simple. Eyeballing the line gets us close then, and by carefully nibbling our way up to it, we shouldn't have any surprises. Please cross your fingers for me though.
I'm pretty sure somebody watching might be saying, why
What the
the
heck
heck
are you
did,
doing?
why did you spend so much time trying to get that other angle?
Yeah, well, that's how I'm feeling just a little bit.
Just to
but
come
it's-
along and do that to it. That's very good.
It looks about right.
Well, on the whole, that's exactly what I was looking for. So, while I'm sure there was an easier way to get here, this is all a learning experience anyway, so it's never really time wasted. Thankfully, with this side completed then, a paper template will let us easily copy the cut over to the other side, as long as we take our time to line up everything properly and put it in the right place. And also flip the template inside out, as of course, we want the mirrored cut, not just a duplicate. This will work though, so we'll set it aside for now and carry on with the driver's unit. Now, maybe you saw this coming, but it turns out the remnant from the first cut is exactly the right angle to match up with the main tube, so all it needs is a little shortening to fit. This is one of those applications where the fab table is still a novelty to me, as although it's being useful on so many levels already, holding short pieces around tubing like this is something I've never had much luck with. And look at me now! Back in place again, it's perfect! And I know this is a lot of back and forth for you, but newsflash, it is for us too. And that's the reality of things, so at least it's paid off. You can really see how the transmission tunnel is tied all the way forward of the engine now, and there's no way that's not going to have beefed things up. Next then, we need what's effectively a hefty washer. So it's over to the drill press to hole saw one out with some plate.
There we go.
There we go.
And with the inner diameter enlarged for an M10 bolt now, a socket is deployed to check clearances, and we're good to tack the parts together before fully going at it. As with any outside joint on thicker material, you want to leave an open corner for weld penetration. So we specifically made the washer a bit smaller than the tube to do just that. Not only is it just plain good practice, it also means that the weld can be smoothed off without removing much of it at all.
Cleaned it up a little bit. Couldn't put it in the lathe because my chuck's not big enough to actually grip completely around that with this down in the bore, but we cleaned it up best we could with a flap wheel, old-fashioned style. And then what we got here finally are some transfer punches. So it comes as a set with a bunch of different diameters, and it has a centering punch right on the end there. So this will slide right down into that hole we drilled in the end of this part. And when you put that in there and whack it with a hammer, that will transfer the center of this part onto the chassis. Beautiful.
Won't that be nice? Generally then, everything's fitting, everything is square, and although the car isn't actually level, we have at least put this tube on the same angle. So, with a Sharpie line ensuring we stay centered on the frame, and a small shim lifting the main tube for welding clearance, there's nothing left to do but tack on the end and button this up. I'd say I've made prettier welds before, but that's what you get for taking a break from this project to do some fencing. No, not that. Not that either. Actual fencing. With wood. Wood! What is this strange substance? Anyway, this'll be more than adequate, and we can now push on with making the 2-bolt flange for the rear, so cue the montage music.
That's awesome, and I think worthy of a subscription if you haven't already. I really like how this came together and the fact that it locates on that firewall dowel pin. Just sits right with me, even if no one will ever see it. The hood is hitting where we expected it to earlier though, so time for a quick trim. Much better. A quick deburr with a file cleans up the cut, and we can stand back to look at our creation. As the legend who is Mr. Leno says, there are plenty of little areas that need to be circled back to, but honestly, I've got no complaints. That's a framing system I'm happy to put to bed and never worry about again.
You know what I've just realized too? This structure bolts in here and there. It's removable. It's a bracket.
A very nice bracket at that, and I think a small 3D printed cap would be a great idea to keep dirt and water out of this, what can only be described as cup. But unfortunately, my Ender 3 isn't really suited for the type of material we'd need for that.
This is though.
Yeah, so when you're offered a new printer at no cost, and there are no strings attached, you say yes. This is the brand new Elegoo Centauri Carbon, and I guess after watching me begin to lose my patience with the bumper in episode 40, they thought I could benefit from an upgrade. So thanks Elegoo, let's see if this really is one. Out of the box, there's just some packaging and screws to remove, a 4.3-inch touchscreen and filament holder to attach, and we're good to go. Not really used to things being that simple. Hey, back away! This is an imposing machine that completely makes my old one look like a printing press. And even though it seems that big gray cubes have been on everyone's feed recently, for what it's worth, I think Elegoo did a nice job on theirs. Plus, the 256mm cubed build volume is among the largest in the segment. There's no auto material selector up top, but it feels like that may just be a matter of time. And while the top glass isn't actually seating down all the way, after climatizing inside, it fell into place. Good. Those corner profiles could be addressed though. There are a few other tiny areas that raised my eyebrow, but I'm a perfectionist and this is a pre-production unit, so I'll overlook them, as I'm just so thrilled to have a fully enclosed printer with a 320-degree hot end, as now we can work with engineering-grade materials like ABS, ASA, TPU, and nylon. As well as, thanks to a hardened steel nozzle, fiber-reinforced versions of those. That said, I'll need a filament dryer first, so if any company watching wants to send one over, hey, why not? The ability for us to create end-use plastic parts now makes this a tool to me, and I think you know how we feel about tools around here. So, with it powered up and the somewhat lengthy calibration complete, let's start a few prints and go over the details. This is Elegoo's first Core XY model, and that's a big deal. As compared to a Cartesian bed slinger like my Ender, a Core XY machine does not use dedicated stepper motors for each axis. Specifically in this case, the bed lowers along the Z-axis, and the print head is operated in the X and Y directions by two isolated motors that coordinate their motion to create the desired outcome. In other words, they turn in the same direction to print in the Y-axis and opposite directions for the X-axis. Maybe that seems pointless to you, but while this makes the design more complicated, the benefit is printing speeds can be pushed all the way up to 500 millimeters per second and 20 meters per second squared. Slightly over 2 Gs of acceleration creates its own vibrations, but the frame is all aluminum and stainless steel, and it does hold things quite firmly. Plus, a feature called input shaping helps to cut down on artifacts like ringing by testing how much vibration the machine creates and adjusting the motion path to compensate. Think of it essentially like active noise cancellation, but for fabricators. This 15-minute pre-sliced benchy turned out not too shabby, with minimal stringing and only a few little defects here and there. And thankfully, this subsequent XYZ cube turned out even better, with only 2 to 3 thousandths of an inch deviation in each direction. Or really, just the Z, and we might be able to tune that out.
I need to put a lot more hours on this thing before I can even begin to talk about reliability, but so far it's consistently churned out what I've asked of it, and that's especially nice, as its built-in camera does not have any AI failure detection to speak of, so it's still quite possible to come back to a bird's nest. On that note, the camera also doesn't have much resolution to speak of at just 360p. What is this, 2004? When paired with a tiny LED then, the resulting time-lapse is verging on pointless, but I can forgive that, as for the pre-order price, Elegoo has handily undercut the new K1C, Q1 Pro, 5M Pro, and especially the X1 Carbon, which I'm sure all have their own quirks as well. So it seems Elegoo has hit a good target of budget-enclosed speed, and I'm excited to see what it can do for us as we push on with the project. We'll have a full review out in due course, but if you're interested in picking one up, there's a link below that, if used, will earn me a small commission.
And regardless of whether or not you're even in the market, I'd just like to say thanks to Elegoo for sending this over, and to all of you for watching and making this possible. Now, back to the project.
We started down this 3D printing sidetrack because I wanted some little caps for the chassis support brackets, and while I've only got PLA on hand right now, it'll work as a prototype, and we'll switch to TPU later. Now, we could use Blender to draw up our part, but as this printer can be accurate to the thousandth of an inch, I figured it was time to dive into Fusion 360 instead. I've used SolidWorks previously, and it's amazing how similar this is, and that you can access this tier of software for free. Just be sure to search for Fusion 360 for personal use, as I missed that myself for a while. This odd little cap should do what I'm looking for, so time to slice it. Elegoo includes this reskinned version of Orca that has the Centauri Carbon's profile loaded, and after running off a test piece, it looks pretty decent. The overhangs printed well with no support, but the layer lines are a bit prominent at the start. And while it fits, I think a few tweaks to the design, including dynamic layer height, a radius instead of a chamfer, and some fuzzy skin should help make this part look less like a 3D printed item. Nice! I'd say mission accomplished, and with it in place, this totally achieves my goal. So the only thing left for us to do today is repeat everything on the passenger side. All of it. Well, at least we got a start. How hard can it be?
Thumbs up for shiny things.
And there you have it then. Both sides are now nice and symmetrical, just the way I like it. And if you like it too, please tell a friend. Everything is lining up and the whole thing just feels so right. It was completely worth our time. But if you think that marks the end for the new structure, you're sadly mistaken. There are plenty more sections to finish off still, but for now, I think we really need to do something about this. Yeah, that's so last week. Thanks for watching, and a very special thanks to the amazing patrons, supers, donators, and subscribers who all support our shenanigans. If you're interested in helping out, there are links in the description below, including a share button. So until next time, keep building. We'll catch you later.